So let us continue the miscellaneous exercise. Now this expression is of the kind a plus b raised to power 4 plus a minus b raised to power 4. So what kind of expansion will this be? I'll have the terms in this expansion like this: 4c0 a raised to power 4 plus 4c1 a raised to power 3 and then b plus 4c2 a raised to power 2 b raised to power 2 plus 4c3 a b cubed, and then there will be last term 4c4 b raised to power 4. Okay, I've written all the terms because these were only 5 terms that I had to write. And if I write these terms, now I have written everything. So I wanted to do it by shortcut, but I have written everything, so that is also okay. So 4c0 a raised to power 4. Now b is being replaced with minus b. So wherever I have got odd parts of b, I'll have a negative sign. So this will be with negative sign. 4c1 a cubed b plus, because b squared or minus b squared will be the same, this will become minus 4c3 ab cubed plus 4c4 b raised to power 4. If I add these terms will get cancelled. This will get cancelled. So I'll be left with twice of the terms having even powers of b, or these terms with 4c0, 4c2 and 4c4, right? So what will be those terms? 4c0, I've written 2 outside because I'll add these. So every term that I will write it will be with plus sign. So 4c0 will be a raised to power a squared raised to power 4 plus 4c2 a squared raised to power 2 and a square minus 1 raised to power 2, right? And the last term will be 4c4 b raised to power 4, that is root a square minus 1 raised to power 4. This will be the expansion. So let us simplify it little bit. So 2 into 4c0 is 1, a square raised to power 4 is a raised to power 8, 4c2 is 6 plus 4c2 is 6, so 6 into this is a raised to power 4 and this is a square minus 1 plus 4c4 is 1, this is a square minus 1 raised to power 4, so I can write it as a square minus 1 whole squared. Okay, now I can further simplify it a little bit and write the answer. So twice of a raised to power 8, this is 6 a raised to power 4 into a square, so this will give me 6 a raised to power 6 minus 6 a raised to power 4, and I can open this square without the use of binomial. I hope this much you can do. This much everyone can do, I am sure of that. A raised to power 4 plus 1 minus twice of a squared, right? So I can write this as twice of a raised to power 8 plus 6 a raised to power 6 minus 5 a raised to power 4 minus 2a squared plus 1. Let me just verify the answer. So everything seems correct. Let's move to the next one. Find an approximation of 0.99 raised to power 5. Okay, using 3 terms of this expansion, first 3 terms of this expansion. So I can write this as 1 minus 0.01 raised to power 5. First 3 terms can be written like this: 5c0 1, right? So 5c0, first term will be 5c0, second term will be 5c1, and here I'll have a negative power. Oh sorry, this is negative term 0.01 raised to power 1. Okay, this will be the second term, and the third term will be 5c2. Now this will be raised to even power. which is 2. This will be the term because here is 1 at the first place, so powers of 1 can be avoided. That won't make a difference to this question. 5c0 is 1, 5c1 is 5, and this term will be negative, right? So minus, this is 5 into 0.01, so it will be 0.05, and this is 5c2, which is 10, into square of this, so this negative sign will be taken care of because it is square, so it will become positive, and 0.01 squared, so if there are two decimals here, the square term will have 4 decimal places, 0001. Okay, this will be equal to 1 minus 0.05, and this is plus, these were 4 decimal places, when I multiply it with 10, these will be 3 decimal places. So this should give you the final result. And what is it? This is 0.95, and I have to add this here, so it will be 0.951. I hope I am not missing anything here, right? You can do it like this, 1.00, right? So when I subtract this is 0.05, so 0.95 will be the solution of these first two terms. If I add this, obviously this will be, yes, this seems correct. Find n if the ratio of the fifth term from the beginning to the fifth term from the end in this expansion. So the question wants you to find the fifth term of this expansion from the beginning and fifth term from the end, and then the ratio is given as √6:1. By equating that ratio with √6:1, you need to find n. Let me show you how we can do that. I need to find fifth term from the beginning, so I'll be finding t5, that is t4 plus 1, which will be equal to nc4 1 by 4th root of 3 raised to power 4, right? And this term raised to power n minus 4. This will be the fifth term, right? Only thing you need to take care when you are writing fifth term, r is 4. So when you know r is 4, you need to raise second term with r and the first term with n minus r, right? So this is the fifth term from end. Let us write it in a little more simplified form. This is fifth term from the beginning, right? We need to still write the fifth term from the beginning, end. All right, so this is 4th root of 2 raised to power n divided by 4th root of 2 raised to power 4. So I'm trying to write it in simplified form. I don't know whether it is required or not, but let us write it anyways. So this raised to 4th power will give me 3 in the denominator, so this will be 3 here. And now another step, I can write it as nc4. This is √2 4th root raised to power n. I can also write it as 2 raised to power n by 4, but I am not doing that for the time being. We will see if we require that or not. So this raised to 4th power will give me 2 here, this is 3, so this is 6. Okay, so this is the fifth term from the beginning, and fifth term from the end of this expression will be nothing but fifth term from the beginning of this flipped expression, which will be like this. If I write this as this plus, now if I expand this, the fifth term from the beginning of this expansion will be the fifth term from the end of this given expression. Okay, so I am writing fifth term from the beginning of this. That will give you the fifth term from the end of your given expression. So fifth term from the beginning of this expression will be t4 plus 1. Just to remind you that r is going to be 4. So nc4. Now I'll raise this to the fourth power. So fourth root of 2 raised to fourth power, and this term will be raised to n minus fourth power. This will be raised to n minus fourth power. Now let us write it in a little more simplified form. nc4, and it has given us one more thing, that nc4 will be cancelled directly. Otherwise there we would have written ncn minus 4. So you can try the other way also of finding the term from the end. How I find the term from the end, I just flip the expression and find that term from the beginning. So nc4 here, and this raised to fourth power will give me 2, and this raised to n minus 4. So I can write this is n minus 4 in the denominator. So what I can write it as is 3 by fourth root of 3 raised to power n. This is how I can write it. You can try yourself and you will find that what I'm saying is correct. Okay, now the ratio from the beginning and end is equal to root 6 by 1. So I'll divide this by this and put it equal to root 6 by 1. So nc4 fourth root of 2 raised to power n divided by 6 by nc4, 3 into 2 is 6, right, numerator. So this is 6 divided by fourth root of 3 raised to power n, and it is equal to root 6 by 1. Now let's see what can be cancelled. This can be cancelled. Okay, and if I take in the numerator, this term will go in the numerator, and it has got nth power, right? This and this has got nth power. So I can write this as fourth root of 6, right? This term and this term, we are multiplying these terms, and I'll write this power as n here, divided by 36. Okay, which is 6 raised to power 2, right? Which is 6 raised to power 2, and this is 6 raised to power 1 by 4 n here, and this is 6 raised to power 2. So collectively what I can do is I can write it as this is 6 raised to power 1 by 2 equals, and on the right hand side I have 6 raised to power n by 4 minus 2. I have taken care of this into this and I have subtracted this. So now to compare these, I have to compare these powers. N by 4 minus 2 should be equal to 1 by 2, right? So n by 4 should be equal to 1 by 2 plus 2, that is 5 by 2. So n has to be equal to 10. And what was that we need to find in this question? It was n. So n is 10. Expand using binomial theorem. So what I'll do is I'll treat it as a binomial. So one of the terms will be this, then minus 2 by x. This will be another term. I'll raise it to fourth power. This is how I'll treat it. Okay, once I'll expand this, then I'll have to expand this raised to certain powers. We will see. So let me expand this first. 4c0 1 plus x by 2 raised to power 4 plus 4c1 1 plus x by 2 raised to power 3 and minus 2 by x raised to power 1. Either you can convert this plus into minus directly, or you can write this term as minus 2 by x. Then plus 4c2 1 plus x by 2 raised to power 2 and minus 2 by x raised to power 2, and then the last term, no, the second last term, 4c3 1 plus x by 2 raised to power 1 and minus 2 by x raised to power 3, and now the last term, which is 4c4 1 plus x by 2 raised to power 0, so I'll not write it, and minus 2 by x raised to power 4. This is how we will write it. Okay, so this was the expansion. Now you see there are these terms. These I'll have to expand separately. But let us write it in a little more simpler form. Then we will expand these terms and write them here. So the first term is, this is 1. This is 1 plus x by 2 raised to power 4. This is 4. So 4. And this is minus 2 by x. So 4 into minus 2 is minus 8. I'll write it as minus 8 upon x. And once I calculate this 1 by x, 1 plus x by 2 cubed, then I'll write it here and multiply it with minus 8 by x. Plus 4c2, that is 6, and this minus 2 squared will become 4. So 4 into 6 will be 24. And here I have 1 plus x by 2 whole squared. So let me open it directly. So x squared by 4 plus 2 into 1 into x by 2. So it will be x, right? And then this x square in the denominator, we don't have to forget it. Now this term will be negative. 4c3 is 4c1, that is 4. 2 cubed is 8. 8 into 4 is 32. So minus 32. And I have 1 plus x by 2 here and 1 by x cubed here. And last but not the least is 1. 2 raised to power 4 is 16 by x raised to power 4. Okay. Now these two expansions you have to expand using the binomial once again. So let me do it. This will be 4c0 x by 2 raised to power 0. So it will be 1. 4c1 x by 2. 4c2 x by 2 squared. 4c3 x by 2 cubed. And then 4c4 x by 2 raised to power 4. Okay, minus, this will be 8 by x, and then you have to expand this one now. 3c0 plus 3c1 x by 2, 3c2 x by 2 squared, 3c3 x by 2 cubed. Right, rest of the terms are simple. Now I want you to write these values yourself, because this is pretty simple now. So put these values and come up with an answer. Okay. And now the last question of this exercise. This is another question of the same format. So what you need to do is, you consider this as one term, this as another, right? So open it as a binomial. So how will you open it? This is third power, right? So you'll start with 3c0 and write 3x square minus 2ax raised to power 3 plus 3c1 3x square minus 2ax raised to power 2 into 3a squared raised to power 1. Okay, plus 3c2 3a squared raised to power 2 and 3x squared minus 2ax raised to power 1. and then the last term 3c3 3x square minus 2ax raised to power 0. You could have avoided this writing this term also, because this is anyways going to be 1. So 3a squared raised to power 3 will be the last term. Now what you need to do is, this is another binomial that you need to expand. This is a square term, right? You can simply square it without using the binomial. Rest of the terms are simple, and you also know these values 3c0, 3c1, 3c2 and 3c3. Now I think it is fair, after doing these many questions, I can expect you to do this question yourself. Okay, what you need to do is, you will write this as 1, open this bracket by binomial once again. Okay, because we need to use binomial, otherwise we know that the cube of this term, we know the formula for cube directly, right? Rather than saying this much, I could have solved this question by now. But anyhow, I won't solve this question. I expect you to do you to do this question yourself. Okay, I hope we have learned binomial theorem very well and will be able to excel in our exams. Thank you.